and welcome to episode 3 of this binary course. Today, we will discuss two methods for multiplication of binary numbers. In this lesson, we're going to cover the logical and arithmetic shift. So here's a quick starter point. Binary shifts can be used for multiplication and division by powers of 2. So if you remember, in all my lessons, we have discussed that the binary numbers are put in the binary table where you use powers of 2. So your numbers would be 2 to the power of 2, or I don't know, something all the way till 2 to the power of 7 we've done in this lesson. So we'll discuss this further in the next few slides. The logical shift. In the logical shift, we only work with unsigned numbers, which means nothing from 2's complement from last lesson. You can easily tell by the word shift that you need to shift the bits in order to multiply. In multiplication, the shift is towards the left since your binary number would be getting bigger. So our question is 20 multiplied by 4. The first thing you need to do is put 20 in the binary table. Then you need to know that 4 is actually 2 to the power of 2. So your shift will be twice to the left, which means that this bit here would move twice and end up here. And the same thing would happen for each and every bit in this table. So let's check. So that is your answer in binary. So you've moved each one twice towards the left-hand side. And then you've got your answer in binary. So if you've got this correct, your answer should be 80, and if you convert it to denary. So you could check this by multiplying 20 by 4 to see if 80 is the correct answer, which it is. So the two things you need to remember, A, is that your shift is based on the power. In this case, it was 2 to the power of 2, so your shift will occur twice. B, add 0 to replace the least significant bit, which is the one all the way on the right. So if you see the 0 over here, this is your least significant bit. Now we can move on to arithmetic shift. Arithmetic shift. Arithmetic shift is actually the opposite of logical shift. That means that it can only be used on signed numbers, which are expressed in 2's complement format. This means that to do arithmetic shift, you need to have the number in 2's complement to then perform the shift. So, the question is negative 36 multiplied by 2. The first thing you need to do is convert negative 36 to binary. For this, you need 2's complement. So you do 36 in binary, flip, and add 1, and that is negative 36. If multiplied by 2, then there would be only one shift to the left, and you would add a 0 to the right. So since it's multiplied by 2, you'll move this over here, and you will replace this empty space after shifting with a 0. So this is what it'll look like. This is what happens after you shift to the left and a 0 added to the least significant bit, which is over here. So if you notice, each bit has been moved only once towards the left. And another thing you need to remember, when you are shifting, you leave the most significant bit in place and then shift the others to the left once. So this is only for arithmetic shift as we're dealing with signed numbers. So you're multiplying negative 36 by 2. So this 1 acts as your negative sign. So you ignore it as if it doesn't exist. And this 1 here, when it's shifted, it's ignored and you pretend it wasn't there. And this binary digit ends up over here. So your answer should be negative 72. You can check this by using the 2's complement table and see if this negative number is equal to positive 72. So what you're going to do is you're going to write 72 over here, negative 72 here, exactly as it is in this answer table. Then you're going to flip it and add 1, and your answer should come out as positive 72, which means that this bit right here should become a 0. Okay? So that's all for today. Thanks for watching and stay tuned for episode 4. Also, the reference to 2's complement. For the reference to 2's complement, click on the video on the left. And for the reference to any other video, visit my channel, Stories, Games, and More. And if you haven't already, the big red subscribe button awaits. Thanks for watching and see you in the next episode.